At this point, you should have already completed the backside of this worksheet. If you have not completed the backside of the worksheet, please complete it before you watch this video. Okay, so I've worked through most of these and I'm going to post the key, but I did want to show you how to work through these two problems. They're a little more difficult. Okay, so we're given all of this, S equals 2 times LW plus LH plus WH, and we're solving for W. So the first thing that we need to do is get rid of this 2. We can do that either by distributing it, or the quickest way would just be to divide by 2 on each side. So once I've gotten rid of that 2, I now no longer need these parentheses. And that's good because I'm trying to get the W by itself, so I need it outside of the parentheses. Okay, now I notice 2 of these terms have W's in them, and the other one does not. So I'm going to go ahead and get rid of the one that doesn't have a W, because the whole point is to get the W by itself. So for right now, I have S divided by 2 minus LH equals LW plus WH. So my LH minus my LH is just 0. Okay, so now I have these 2 terms that both have W's in them, but I really only want one W. Now if I divide by W, then I end up with an extra W on the left side that I don't want. And if I try to move one of these, then there's W's on both sides. So what I really want to do is think about, how can I make this into just a single W? And the answer is factoring. A lot of the times when you have a problem that's difficult to solve for, factoring will usually make it easier. So what I mean is I'm going to factor out the W from both terms. If I factor out the W from this first term, I'm just left with an L plus, and then I factor out the W from the second term, I'm left with just an H. And if I want to double check to make sure I did this correctly, I can always use that distributive property of multiplication and distribute the W. When I multiply it back out, I should end up with what I started with. So W times L is WL, plus W times H is WH. Now, even though the W and the L are backwards, the W and the H are not. Multiplication, the order doesn't matter, so WL is the same as LW. So this checks out. So I'm going to go ahead and rewrite what I did. I factored out the W so that I only have one W. Nothing's changed on the left yet. Now that I have that one W, it's being multiplied by L plus H. So to get rid of the L plus H, I'm just going to divide by L plus H on both sides. Here they'll cancel out. So we're just left with W equals S over 2 minus LH, all divided by L plus H. And this is okay if you leave it in this form. We don't really like to see fractions inside of fractions, so we could rewrite this. Has S divided by 2 times L plus H minus LH divided by L plus H. Okay, let's look at the next one. We're solving for pi here. Now, this is going to be very similar. Both terms on the right side have pi in them. So I really just want a single pi. So if I want to turn two terms with pi into a single pi, I'm going to factor out the pi. So the first term, when I factor out the pi, I'm left with 2r squared. And in my second term, if I factor out the pi, I'm left with 2rh. And all of this is equal to a. So I want that pi by itself. I need to get rid of all of this, so I'm going to divide by all of that. And whatever I do to one side, I have to do the other side. Got to keep it equal. Alright, so then this entire term will cancel. And our final looks like a divided by 2r squared plus 2rh is equal to pi.